Welcome back to Tightwad Workshop. Today we're going to be restoring these 3 rusty old bit braces to working condition. I do want to point out that this is real, genuine rust on these tools. I didn't just smear some mud on them like some of those phony tool restoration channels you might have seen. Now, a bit brace is still a perfectly usable tool for the 21st century, although you may struggle to find a full set of bits for a reasonable price these days. Here in Australia, you'll probably struggle to find metric-sized bits for these tools as well. Bits and braces were already mostly replaced by electric drills in the 1970s, when we changed over to the metric system, and so metric brace bits are pretty rare around here, or at least I've never seen any. Now, if we're comparing in purely financial terms, a cheap cordless drill and a set of spade bits will do pretty much anything that a brace and bit will do. But the old tool can still make sense if you live someplace with unreliable electricity, or if you just like using old tools. Now, I'm a sucker for buying half-broken tools that I don't need from garage sales and trash and treasure markets, and I've picked out these 3 braces for us to fix up today. This one is a fancy version with a ratcheting mechanism on the chuck. This is a slightly less fancy version, but of course that means that there's fewer things to go wrong with it. And this one's an even more basic version that doesn't even have a chuck. This style is called a Spoffor brace, and this one was probably made in the 1800s. It's had a bit of a hard life, and it's missing its original thumbscrew. But that's something we'll try to fix in this video. Now, I normally use an electrolysis tank to get the rust off old tools like these, but unfortunately on these braces I can't remove the spinner handles. And if I leave those submerged underwater in the tank for 24 hours, it's going to ruin them. So instead, I'll be using this wire wheel on this bench grinder. Now, don't be tempted to fit this style of wire wheel onto an angle grinder like this. These tools spin much faster than this wire wheel can cope with, and you'll end up with bits of wire shrapnel flying in all directions. Now, they do make wire wheels to fit onto angle grinders like this, but they usually have this sort of twisted knot construction so that they stay in one piece while they're spinning. These wheels will still occasionally throw a bristle off, even if you've mounted them onto this kind of grinder, so it's a really good idea to wear eye protection. I usually use a full face mask, but the bare minimum is a set of eyeglasses. Let's start by removing this grinding wheel from the grinder and fitting this wire wheel in its place. Our next step will be removing the heads from the 3 braces. This one's held on with 3 screws, so we'll just unscrew them and remove the head. Our Spoffor brace doesn't have any screws holding the head on, so I'll wrap this piece of leather around the quill to protect it from my pliers. Then I should be able to unscrew the head from the quill. Removing the heads lets us clean off this rust from the quill bearing as well. This brace has a simple slip-fit attachment for the head. The wire wheel's a very dirty rust removal method, and since I'd rather not get a lot of rust embedded in my woodworking bench, let's move outside to the welding bench for the next steps. It's usually a good idea to clamp the grinder to the bench, because otherwise they tend to vibrate their way onto the ground. So now we can put on our eye protection and begin. It looks like this particular wire wheel isn't very well centered on its hub. Move the workpiece gently against the wire wheel. We're letting the wheel do the work for us. As you can see, even thick rust doesn't take very long to remove. After a few minutes of work, the chuck sleeve looks pretty good. Now we'll work on our Spoffor brace. I'm expecting a few shouts of outrage in the comments about how I'm destroying the tool's value by removing the patiner. But this example is going to need a welded repair, so the patiner will be lost in any case. Once again, a few minutes of work removes many years of rust. I'll also use the wire wheel to clean up our box of bits. This one looks like it's spent a few years buried underground. You'll need to hold the bit at different angles to clean each of its surfaces. That's definitely not factory fresh, but once we sharpen it, we should have a perfectly usable tool again. There were a few areas of the brace frames that I just couldn't reach with the big wire wheel. but this smaller drill-mounted wire wheel reaches them easily. Now we need to disassemble and clean the chucks from our braces. Once you've unscrewed the chuck shell, the jaws are easy to remove. We want to remove the old grease from these parts, and I find that some kerosene and a toothbrush works well for this job. It's usually best to use somebody else's toothbrush though, because the kerosene's going to leave a nasty taste on it. So now that we've finished the cleaning process, we've uncovered a few markings that will tell us a bit more about these tools. This is the newest of the three braces. It's a Stanley A78 12-inch Mark II. And as an Australian, I'm duty-bound to do this. Since it has wooden rather than plastic handles, it was probably made somewhere in the late 1960s. Our second brace also has some interesting markings. It's a John S. Frey & Company No. 8 made in Bridgeport, Connecticut. I haven't been able to find much information about this particular model, so I'll have to guess it as being made somewhere in the early 20th century. It did travel a decent distance to arrive here in Canberra though. Our final brace only has one visible marking. But I've been able to find some photos of a very nice example of the same model on the Jim Bode Tools website. I don't have any connection with that company, but if you'd like to find a nice brace for yourself without all the fooling about that I'm about to do, you might want to go and pay them a visit. Our example has the same rebates on this handle for cast pewter rings as the one in the photos, so I'm fairly confident in saying that this one was made pre-1920. Now this one's lost its thumbscrew at some point, and a previous owner has replaced that with this bolt. The opposite side of the brace is supposed to have a threaded section to engage with the thread on the thumbscrew, so it looks like that's been drilled out at some point to make the bolt work. So we're going to have to find a way to fix both of those problems. Let's head over to the lathe and see what we can come up with. We'll start by measuring a suitable length of steel stock and securing it in the collet chuck. Now I'll use a suitable tool to face off the end of the stock. It's midwinter here in Canberra, and because the oil in the lathe's headstock is very cold, it takes a lot longer than usual to come up to speed. Once we've faced off the end, we can reduce the diameter to 3/8 of an inch to make our bolt. That should be getting pretty close now, so let's check our measurement. Well, we were aiming for 0.375 inches, but that's close enough for government work. Next, I'll swap out the tool for this little pointy version and make a chamfer on the end of the bolt. That'll make it easier to start the threading die. I'll also put a chamfer on the bolt shoulder here, so that the finished thumbscrew won't scratch the brace when we tighten it up. We'll use this die to cut a 3/8 inch NC16 thread onto the bolt. I'm going to use the lathe's tailstock to help me align the die correctly with the end of the bolt while I start the thread. Once everything's lined up, I'll turn the lathe chuck by hand to cut the bolt thread. I'm winding the tailstock ram inwards as I go to keep a little bit of pressure on the die for the first couple of turns. Once the die is securely threaded onto the bolt, we don't need to follow it with the tailstock anymore. It'll hold its own alignment now. It's a good idea to reverse wind the tap a little bit every couple of turns to break off any metal chips. This reduces the pressure on the die and it helps it cut easier. Once we've cut the full depth of the bolt thread, we can remove the die. I usually give the threads a hit with a wire brush at this point to remove any remaining metal chips. Now we can fit a parting tool to cut our raw bolt from the stock. Parting off is a slow process on a tiny lathe like this one. It looks like my parting tool could use a little sharpening too. Now we can put our bolt in the vise to remove this little nub that the parting tool left behind. A few strokes with a file should make quick work of it. Now we need to cut a piece of scrap to make into the wings of our thumbscrew. That should do nicely. I'll use my TIG welder to attach the wings to the head of our thumbscrew bolt. I'm still at the early stages of learning TIG welding. I'm just a little bit past the constant angry swearing stage. If you can do it well, it's a good, precise process for this kind of job. I'm not yet doing it well, but as we said before, that's close enough for government work. We'll also need to weld the hole closed on the brace frame, so that we can drill and tap it to 3/8 inch NC16 as well. This TIG welding rod is high carbon steel, so it's important to let it cool down slowly. If we just dunk it in water, it'll harden, and regular high-speed steel drill bits won't be hard enough to drill through it. Once the weld is cooled, we can drill out the hole to 5/16 of an inch, or approximately 8 millimeters. Then we can use a tap to cut the threads into the hole. Once again, I'm reversing the tap every half turn to break off the chips. This reduces the amount of force on the tap. Once we've tapped the full depth of the hole, we can unscrew the tap. Now we can file the wings on our thumbscrew into a suitably elegant shape. Using this movement with the file will automatically generate a nice smooth curve. Unfortunately, we don't have enough room on this side to do that, so we need to use a different angle. After a few minutes of rough filing, and a bit of finishing with a smooth file, our thumbscrew looks pretty adequate. And if we're lucky, it might even work. Once again, close enough for government work. Now we need to remove the remaining old paint from the wooden parts. A scraper is a good fast way to do this. Then we'll finish the job with some light sanding. Our Spoffor brace has these wire loops holding its handle together. I don't like these sharp ends, so let's remove the wire and make a better repair. We'll need to clean up these surfaces to give our glue something to cling to. The best way to do that is to lay some sandpaper flat on our bench top, then rub the pieces on it. This handle is most likely made from rosewood. It's a very pretty wood, but it's also very rare and expensive these days. I'll prepare the other piece in the same way. Once the parts have all been cleaned, we can glue them back together with some cyanoacrylate glue, or superglue. I'll apply a thin layer of glue to one of the pieces, then fit the parts together and secure them with a wooden clamp. I'll be replacing the wire ties with this heavy waxed cotton thread. We'll start by wrapping the thread over its own loose end. Now I'll place this separate loop of thread across our binding. We'll use this in a moment to finish things off. Now we continue winding the thread around the handle, keeping it nice and tight. Finish by passing the loose end of the thread through our loop, then pulling the loop out from underneath the binding. Now we just need to trim the loose ends and our binding is complete. Next we can replace the heads on our braces. The Spoffor brace head screws back on. The Fray brace head pops back in place. But we need to make a repair to the Stanley brace head. This crack is starting to open up, aligned with two of the screw holes. So we'll rotate the hub slightly and drill 3 new holes away from that crack to help hold it shut. I'll just make spot marks with the drill to start with. Now we can drill the holes to their correct depth. And insert the screws. The head's a little stiff to turn, but this brace has an oiling hole here, so let's add some lubricant. Now we need to grease the chucks of the Fray and the Stanley braces. Any kind of grease will be better than none, but I'm going to use this leftover wheel bearing grease from the trailer bearing replacement video. Smear a small amount of grease on the chuck threads. Then apply a little to the ends of the chuck jaws, like this. Now we can refit the jaws into the chuck sleeve and screw it back onto the brace frame. For the fray brace, it's easier to install the jaws in the chuck first, and then fit the chuck sleeve over the top. We're on the home stretch now, we just need to apply some finish to the wooden parts. I like to use raw linseed oil because it's cheap, it looks nice, and I like its aroma. Just put a small amount of oil onto a rag, then rub it into all of the wooden parts. If the wood's very dry, you might need to apply several coats, as it'll soak into the wood. Since the weather's cold here at the moment, this will probably take a few days to fully dry. When you've finished with the wooden parts, rub the rag over the metal parts as well. The linseed oil won't do the metal any harm, and it helps to slow down any future rusting. So there's our 3 vintage hand braces back from the dead. Now, this video's run a little bit longer than I thought it would, so if you want to tune in next time, we'll cover how to sharpen and repair the bits, and how to use the brace to drill clean and accurate holes. That's all for now. Thanks for watching. Tightwad Workshop is filmed in front of a live studio audience.